Hello. In the last lesson we started to meet the idea of hypothesis testing, which involved setting up some hypotheses and a test statistic and deciding if it was one or two-tailed. I'm going to ask you to have a quick go at this. You can either do it in your head or you can write down a piece of paper somewhere, and then we'll have a look at some answers and see if we can do the stuff from last lesson. Okay, if you haven't already, pause the video, have a go at this. So in a game, 10 fair dice are rolled, you win a prize for every 6 you obtain. Mike plays this game and gets 1-6. He suspects that the chance of getting 6 is lower, because you wouldn't expect to get 1-6 if you roll 10 dice. Write down our test statistic. So if we roll 10 dice, this is going to be modelled using the binomial distribution. So our test statistic is going to be x is a binomial 10 1/6. So this is what we're going to be using to do our calculations on. Our h0 is going to be the probability of a 6 is 1/6, so this is fair. And our h1 is going to be probability of 6 is less than 1/6. So this is biased against a 6. So this is actually a one-tail test, because there's only one possible option here, which is less than a 6. So this is the stuff we looked at last time. It's picking out some hypotheses, something we can test. This is called a test statistic. This is what we're going to be doing our calculations on. And this is a one-tail test, because there's only one possible option when you're looking at less than 1/6. Okay. Today we're going to look at finding critical regions, which is the region where we can say we're going to go with this h1 here rather than our h0. Or if it's not in the critical region, we're going to stick with h0 as the hypothesis we believe is true. So a critical region, if we have a look at this graph, so here we have a binomial distribution. We've got n is 10 and we've got p is this 0.4. So you can see in the middle we've got lots of options. The most likely option is 4, which you'll notice is actually n times p. 10 things, probability 0.4, most likely outcome is 4. And then 3 and 5 are quite likely, and 2 and 6 are a little bit less likely, but after that we start to tail off to what we call a tail here. So if we're doing a 5% test, this is going to be a one-tail test because it's greater than, and you'll notice as it's greater than we're looking at the greater tail. So what we want to do is look at this area down here and work out where is the 5% of least likely outcomes. So probability x is 10 is tiny, and 9 is also tiny, and 8 is also tiny. And if you add up all of these things, 8, 9, 10, you get something that's about 1%. So that's a less than our 5% significance. If you add in the next one, if we add in 7 as well, we get a probability of over 5. So this thing, 8, 9 and 10, is our 5% of the least likely outcomes. This is what we call our critical region. 7, the probability of getting 7, 8, 9 and 10 is bigger than 5%, so 7 will not fit into our 5% critical region. So this area here is our acceptance region. If we get one of these outcomes, so anything from 0 successes up to 7 successes, we will conclude that we accept h0. So this here, acceptance region, is to accept h0. This region here, the critical region, is to reject h0. Accept h1. Because the chance of this happening, if h0 is true, is so tiny, we don't believe h0 was actually a true hypothesis, and we'd rather accept h1 in its place. So if we're getting one of these results like 8, 9 and 10, chances are the probability was bigger than 0.4. This is the entire point of a hypothesis test. We're looking at the significance up here, and going, let's find the 5% of least likely outcomes, or 10%, or 1%. In this case, up to 8 or higher is 1.3%, and 7 is too big. Once you add up 7, you end up with 5.5 something. So that's not going to work. So we're going to have to stop with 8. So 8, 9, and 10 are our 5% critical region here. A critical value is the first part of the critical region. It's like the dividing line. So it falls before the acceptable, after the acceptable region. So in the last case, the critical region is actually 8. So the critical value is 8, and the critical region is 8 or higher, or 8, 9, and 10. So you can either use your calculator to find these probabilities out, or you can use the table. I'm going to suggest using the calculator, and we'll do most of the stuff today using the calculator. Okay, just to give you a quick idea about how these critical regions look on diagrams. Okay, if we have a two-tailed test, and this two-tailed test has not equal to, and it's a 5% test, we need to keep open two options. It could be bigger than or smaller than. So it will be 2.5% this side and 2.5% this side. So you'll need to find the 2.5% of least likely less than outcomes and 2.5% of the least likely greater than outcomes. For a one-tailed test, if the probability is greater than 0.5, we're ignoring this as a possibility. So we're just after the 5% of greater than outcomes. 5% of least likely greater than outcomes. So in this one, we had to half it and put one half there and one half there. If it's a less than one-tailed test at 5%, we're just doing the 5% of least likely outcomes this side. So it'd be like x is less than 3, x is less than 4, x is less than 5, those kind of things that we're going to test. Okay, our first hypothesis test to find some critical regions. So they've actually given us here the hypotheses, and they've given us our distribution. Using a 5% significance level, find the critical region for this test. Okay, because this has got p is greater than in here, we know this is a one-tail test. And because it's greater than, we're looking for when is the probability that x is greater than or equal to something is less than 5%. So this is what we're trying to find. This is our tail. We want to find probability x is greater than, if you think back to the diagrams, we're after like this 5% here. So we're after what number do I put in here? The biggest number that I put in here to get 5%. Because there's only 6, we might as well start off trying 6. So we have n is 6, p is 0.35, and we're going to start off by testing 6. So I'm going to grab my calculator, I'm going to use distribution mode. I'm going to be using binomial CD. So let's do 6 or greater. That is the same as just equal 6, but let's do it this way. So 6 for n, 0.35, press equals. Because this gives us less than or equal to. So we've got to remember, when we're doing 4, 5, 6, if we want 6 or greater, we need to do 1 minus probability x is less than or equal to 5. So we're going to put a 5 in here. So this is 1 minus 0.99816. Which comes out to be tiny. This is very, very small. So we should start making a list. Probability x is greater than or equal to 6 is 1.84 times 10 to the minus 3. If we were to do 5 or higher, then we're going to have to do 1 minus less than or equal to 4. Menu, distribution, binomial CD, variable. So 4, 6, 0.35. Press equals, we get this. This is 1 minus 0.9776, which is actually 0.0224. So probability x is greater than or equal to 5 is 0.0224. Now we could go, this is pretty close to 5%, I'm going to guess that this works, but that wouldn't be maths. So we also need to do 4, so this is 1 minus 3 or less. So if I go back to here, key in 3, this is 1 minus 0.8826, which is 0.1174. Okay, so looking at these numbers, we're after the first time this drops below 5%. So the chance of being greater than or equal to 6 is tiny. This one's about 2%, this one's 11%. So our critical region is actually x is greater than or equal to 5. And our acceptance region is x is less than or equal to 4. So if you get 5 or higher, we have reject H0. And 4 or lower, we have accept H0. Oh, let's move that up. So if we have greater than or equal to 5, we're going to reject H0, because that is the 5%, well in this case 2.24% of least likely outcomes. And if x is less than or equal to 4, we're going to accept H0. If we have a look at the last bit of the question, state the actual significance of this test. The actual significance, which is why it's worth writing these down, is 2.24%. Because that is the actual size of our critical region. So we could then do this experiment. If you have an answer of 5 or 6, we're not going to believe H0 was true. It's too unlikely. It's only got a 2.24% chance of happening. If we get one of these ones, these are our likely outcomes, less than or equal to 4, we're going to accept H0. And that is that the probability was actually 0.35. I've added a few more nice, quite easy examples for us to have a look at until you get the idea of doing this. So this again is a one-tail test because it's just got the less than. A 10% significance, and this uses binomial 20. So we're after, if you imagine the graph is going to look a bit like this, it's got bars obviously, but we're after this bit here of size 10%. 10% of least likely outcomes for the less than, because you've got a less than side here, so we're doing the less than bit. So in this case we're looking at probability x is less than or equal to something is less than 10%. We want to know the biggest number that goes in here that allows us to find the 10% of least likely outcomes. So we're going to be using binomial 20, 0.3, because that's what's in H0. So if I put, let's say 5, we start off with 20, 0.3, key this in. This is already 40%, this is way too big. Let's start maybe with 2. 3%. So let's start making a note of these because we're going to use these. So probability x is less than or equal to we did 2. We did 2. 2 is 0.0355. Now you'll notice I didn't do 1 minus, whereas in the previous example I did. This is because the calculator gives us this bit here. So it gives us less than or equal to as part of binomial CD. Because this is too small, we're going to test 3. This is kind of trial and error in some some cases, probability x is less than or equal to 3 is actually 0.107. So this one here is too big. So if our test is 10%, we're going to have to stick to this. So the critical region is actually x is less than or equal to 2. And the actual significance is 3.55%. There are some questions that will word it, find a tail that is as close as possible to 10%. And if they give that as wording in the question, we might actually go with this tail instead because it's closer to 10%. But you have to follow the wording that's in the question. We've not been chosen to do as close as possible to 10%, so we're going to have to stick with the one that is less than 10%. You might look at this example here and think nothing has changed, but there's a very subtle change in the question, and it's this has changed to a not equal to. I'm going to keep the stuff that I've got here, but we're going to amend it a bit. So now we are not looking for a 10% one-tail test. We're looking at a two-tail test, which means it's 5% here and 5% here. Now I can see from this one, this is still the correct one, because this is still less than 5%. We also need to do the upper tail, which is probability x is greater than or equal to something is less than 5%. And we need to find the smallest number that goes in here to make this work. So we're going to start needing to try some numbers. Now this is kind of symmetrical, and it's kind of symmetrical about 7. And I got this 7, that's 6, and I got this 6 from doing 0.3 times 20, which gives us 6. So I'm going to try, if this one was about 4 away, I'm going to try probability x is greater than or equal to 10 and see if it works. Remember, this is 1 minus probability x is less than or equal to 9, because this is the one we can get from our calculator. So if I grab my calculator and put a 9 in here, we get 1 minus 0.95204, which is 0.048. Oh, that's close. 048. Yeah, 0. So, this is pretty close. This is too small. In theory, we should test one that's a bit bigger, so probability x is less than or equal to 9. Because this one is too small, we're after something that's too big to show that we found the dividing line. So if you remember, this is 1 minus 8, so I'm going to put 8 in here, which gives us 1 minus 0.8867, which gives us 0.1133. So you'll notice this is too big, this is too small. Because we're after something that's smaller than 5%, we're going to go with this one. So our critical region is actually x is less than or equal to 2, or x is greater than or equal to 10. So that gives us our two bits of critical region. We've got this bit of critical region here for the less than, and this bit of critical region here for the more than, the greater than part. So if we were to do this experiment, whatever it might be, and get a result that's less than 2 or greater than, less than or equal to 2 or greater than or equal to 10, we would reject H0. Because you remember, critical region, we reject H0. If we get a result that's inside this, so 3 all the way up to 9, and anything in between, we would accept H0 because this is sufficiently likely. Okay, if you've got a stats textbook, in the first version of the stats textbooks, this example is actually printed incorrectly, and the way they find probabilities isn't correct. If you've got a second version of the textbook, it should have been updated. I can't remember if they've updated the online textbook or not yet, but we're going to have a go at this example, and then it's time to have a go at some questions. So we've got our hypotheses set up here. we can see because we've got a not equal in here, this is a two-tail test. And they've said probability in each tail should be as close as possible to 1% to get 2% significance overall. So what we want is basically our shape here, from all made up of all the bars. We're after 1% here and 1% here. So we need to find two things. We need to find probability x is less than or equal to something is approximately 1% for this tail, and probability x is greater than or equal to something is approximately 1% for this tail. Let me get rid of this because we're going to need a lot of space for this diagram. Is approximately 1%. So we've got two tails here, and we want these two tails to be around 1%. So let's start off. Lower tails are always easier to do. So let's grab our calculator and have a go at some calculations. So we've got 40 and 0.25. So we're going to go on binomial CD, variable. I'm going to key in my 40 and my 0.25. And we're going to try some things. Let's try 5 to start off with. That's 4%. Let's try 4. That's about 1%, but it's a bit big. So probability x is less than or equal to 4 equals 1.6%. Okay, let's try going one more up. 5. Probability x is less than or equal to 5 equals, and this is 4.33%. So which one of these is closer to 1? Oh, we should really do the one that's the other side. So probability x is less than or equal to 3 equals, let's do 3 as well. So this is times 10 to the minus 3. So this is 0.470%. If we turn it into a number. Okay. Which one of these is closer to 1%? And the answer would be actually this one. Because if we, this is 0.6 away from 1. This is less than 0.6 away from 1. Because if we were to take 1 and take away 0.6, we end up with 0.4. So this one actually ends up being closer. Let's just make sure. So if we go menu 1 and do 1 minus answer. So this one here is actually closer. So our first critical region is x is less than or equal to 3, which has a probability of 0.47%. To do the upper critical region, this can be a lot more difficult because we've got to remember that we've got to do 1 minus. So let's look for some answers, and we're looking for about 0.99. So if we did menu, distribution, binomial CD, variable, so I'm going to put in my 40 and my 0.25. And we're going to key in some numbers here, and we're going to look for about 0.99. So if I try 12, that's miles away. 15, 0.97, 19, that's a bit far. 17, 0.95, 18. Okay, so 17, 18, somewhere around here. So if we want to do probability x is greater than or equal to 19, this is 1 minus probability x is less than or equal to 18. If you're struggling with this binomial probability stuff, you need to go back and review and recap chapter 6, because that was about using binomial distribution. So greater than or equal to 19 means we need 18, 19, we want all of this stuff. So we need to do 1 minus x is less than or equal to 18, so we can use our calculator. So if we go back and key in 18, this is 1 minus 0.9983, which is 0.0017. We should also go one more this way, so probability x is greater than or equal to 18, which is 1 minus probability x is less than or equal to 17. If we key in 17, we get 1 minus 0.99534, which is 0.00466. We should probably go one further as well, so probability x is greater than or equal to 17, just so that we get two things either side. So this is 1 minus, we're going to do 16 for this one. 0.98843. So we get 0.01157. Looking at this, the one that's closer to 1% is actually this one. Because this one is like 0.5 something away, and this is just 0.1 something away. So a critical region is actually x is less than or equal to 3, or x is greater than or equal to 17. Now I would suggest keeping these numbers, because part B is the actual significance of the test. So for that, we're going to do the 0.47% from here, plus the 1.157% from there, which gives us menu 1, 0.47 plus 1.157, which gives us an actual significance of 1.63% as our actual significance. Because this tail here is almost 0.5%, this tail here is 1.1%, so together we get our 0.63. So that is our actual significance. So you'll notice that finding lower tails is much easier than finding upper tails, because the calculator gives you less than or equal to. When you're doing upper tails, you need to do 1 minus, and then remember to reduce this by 1, because we want 19 to be included for this one. So we need to do 1, take away everything up to and including 18. So we've got our critical region here, which is this critical region plus this critical region. And together, this gives us a significance of 1.63%. I'd suggest not doing question 1, but starting on question 2. There are a couple of other questions that have incorrect answers or incorrect significances. And if you've got the old version of the book, or if the textbook, the online version of the textbook happens to have the old questions still in it, or the old answers, you need to make sure you're looking at these. So for question 7, the answer is wrong. It should actually be x is less than or equal to 2. For question 5, they use a 5% significance. A 5% significance for this 1%. So most of them are okay, but this one has an incorrect answer, and this one, the significance level, they used 5% in the book. Have a go at some of these questions. They are quite tricky. Remember that you can get full written solutions online using the link on the online textbook page.